An aqueduct is a watercourse constructed to convey water. In modern engineering, the term aqueduct is used for any system of pipes, ditches, canals, tunnels, and other structures used for this purpose. The term aqueduct also often refers specifically to a bridge on an artificial watercourse. The word is derived from the Latin aqua and ducere. Aqueducts were used in ancient Greece, ancient Egypt, and ancient Rome. In modern times, the largest aqueducts of all have been built in the United States to supply the country's biggest cities. The simplest aqueducts are small ditches cut into the earth. Much larger channels may be used in modern aqueducts. Aqueducts sometimes run for some or all of their path through tunnels constructed underground. Modern aqueducts may also use pipelines. Historically, agricultural societies have constructed aqueducts to irrigate crops and supply large cities with drinking water. Ancient aqueducts, although particularly associated with the Romans, aqueducts were devised much earlier in Greece and the Near East and Indian subcontinent, where peoples such as the Egyptians and Harappans built sophisticated irrigation systems. Roman-style aqueducts were used as early as the 7th century BC, when the Assyrians built an 80 kilometers long limestone aqueduct, which included a 10 meters high section to cross a 300 meters wide valley, to carry water to their capital city, Nineveh. India. The Indian subcontinent is believed to have some of the earliest aqueducts. Evidence can be found at the sites of present-day Hampi, Karnataka. The massive aqueducts near River Tungabhadra supplying irrigation water were once 15 miles long. The waterways supplied water to royal bathtubs. In Oman from the Iron Age, in Salu, Bat, and other sites, a system of underground aqueducts called filage or canets were constructed, a series of well-like vertical shafts, connected by gently sloping horizontal tunnels. There are three types of filage: Dodi with underground aqueducts, Gailai requiring a dam to collect the water, Aini whose source is a water spring. These enabled large-scale agriculture to flourish in a dry-land environment. Persia. In Persia from early times a system of underground aqueducts called canets were constructed, a series of well-like vertical shafts, connected by gently sloping tunnels. This technique taps into subterranean water in a manner that delivers water to the surface without need for pumping. The water drains relying on gravity, with the destination lower than the source, which is typically an upland aquifer. Allows water to be transported long distances in hot, dry climates without losing a large proportion of the source water to seepage and evaporation. Petra, Jordan. Throughout Petra, Jordan, the Nabatean engineers took advantage of every natural spring and every winter downpour to channel water where it was needed. They constructed aqueducts and piping systems that allowed water to flow across mountains, through gorges and into the temples, homes, and gardens of Petra's citizens. Walking through the Siq, one can easily spot the remains of channels that directed water to the city center, as well as durable retention dams that kept powerful floodwaters at bay. Greece. On the island of Samos, the tunnel of Euparinos was built during the reign of Polycrates. It is considered an underground aqueduct and brought fresh water to Pythagorean for roughly 1,000 years. Roman aqueducts were built in all parts of the Roman Empire, from Germany to Africa, and especially in the city of Rome, where they totaled over 415 kilometers. The aqueducts supplied fresh water to public baths and for drinking water, in large cities across the empire, and set a standard of engineering that was not surpassed for more than 1,000 years. Bridges, built in stone with multiple arches, were a distinctive feature of Roman aqueducts, and hence the term aqueduct is often applied specifically to a bridge for carrying water. South America. Near the Peruvian town of Nazca, an ancient pre-Columbian system of aqueducts called puquios were built and are still in use today. They were made of intricately placed stones, a construction material widely used by the Nazca culture. The time period in which they were constructed is still debated, but some evidence supports circa AD 540 to 552, in response to drought periods in the region. The Guayabo National Monument of Costa Rica, a park covering the largest archaeological site in the country, contains a system of aqueducts. The complex network of uncovered and covered aqueducts still functions well. The aqueducts are constructed from rounded river stones, which are mostly made of volcanic rock. The civilization that constructed the aqueduct system remains a mystery to archaeologists. It is suspected that Guayabo's aqueducts sat at a point of ancient cultural confluence between Aztecs, Mayans, and Incas. North America. When Europeans saw the Aztec capital Tenochtitlan, early in the 16th century, the city was watered by two aqueducts. One of these, Chapultepec Aqueduct, built circa 1420, was rebuilt by the Spanish almost 300 years later, originally tracing part of its path over now-gone Lake Texcoco. Only a fragment remains in Mexico City today. Sri Lanka. Extensive usage of elaborate aqueducts have been found to have been used in ancient Sri Lanka. Modern aqueducts. In modern times, the largest aqueducts of all have been built in the United States to supply the country's biggest cities. The Catskill Aqueduct carries water to New York City over a distance of 120 miles, but is dwarfed by aqueducts in the far west of the country, most notably the Colorado River Aqueduct, which supplies the Los Angeles area with water from the Colorado River nearly 400 kilometers to the east, and the 701.5 miles California Aqueduct, which runs from the Sacramento-San Joaquin River Delta to Lake Perris. The Central Arizona Project is the largest and most expensive aqueduct constructed in the United States. It stretches 336 miles from its source near Parker, Arizona to the metropolitan areas of Phoenix and Tucson. An aqueduct in New Zealand, the Oamaru Borough Race, was constructed in the late 19th century to deliver water about 50 kilometers from the Waitaki River at Currao to the coastal town of Oamaru. Design. Open channels. The simplest aqueducts are small ditches cut into the earth. Much larger channels may be used in modern aqueducts. For instance, the Central Arizona Project uses 7.3 meters wide channels. A major factor in the design of all open channels is its gradient. A higher gradient allows a smaller channel to carry the same amount of water as a larger channel with a lower gradient, but increases the potential of the water to damage the aqueduct's structure. A typical Roman aqueduct had a gradient of about 1 to 4,800. Underground tunnels. Aqueducts sometimes run for some or all of their path through tunnels constructed underground. A version of this common in North Africa and Central Asia that has vertical wells at regular intervals is called a qanat. One historic example found in Syria, the Qanat Firaun, extends over 100 kilometers. Pipes. Modern aqueduct may also make extensive use of pipelines. Pipelines are useful for transporting water over long distances when it needs to move over hills, or where open channels are poor choices due to considerations of evaporation, freezing, pollution, or environmental impact. They can also be used to carry treated water. Uses. Historically, agricultural societies have constructed aqueducts to irrigate crops. Archimedes invented the water screw to raise water for use in irrigation of croplands. Another use for aqueducts is to supply large cities with drinking water. It also helped drought-prone areas with water supplies. Some of the Roman aqueducts still supply water to Rome today. In California, United States, 3 large aqueducts supply water over hundreds of miles to the Los Angeles area. 2 are from the Owens River area, and a third is from the Colorado River. In modern civil engineering projects, detailed study and analysis of open channel flow is commonly required to support flood control, irrigation systems, and large water supply systems when an aqueduct rather than a pipeline is the preferred solution. In the past, aqueducts often had channels made of earth or other porous materials, but significant amounts of water are lost through such inlined aqueducts. As water gets increasingly scarce, these canals are being lined with concrete, polymers, or impermeable soil. In some cases, a new aqueduct is built alongside the old one because it cannot be shut down during construction. Notable aqueducts. Ancient Greek aqueducts. The Eupalinean aqueduct on the Greek island of Samos. Roman aqueducts. The Pont du Gard, constructed in the 1st century, in southern France. The Aqueduct of Segovia, an aqueduct bridge, is one of the most significant and best preserved ancient monuments left on the Iberian Peninsula. Segovia, Spain. Other aqueducts. Pont Mantable Aqueduct in Santiago de Compostela, Spain, 12th century. The Jerwin Aqueduct, built by the Assyrian king Sennacherib, dated to 688 BC, as part of the water supply system to the city of Nineveh. Aqueduct Malta, built in the 16th century to transport water from the old capital city of Malta, Mdina, to the new capital city Valletta. Today, only part is visible in the localities of Balzan, Birkirkara, and Santa Venera. Aqueduct Street Clement, Montpellier, France, 17th century. Bar Aqueduct, Montenegro, 16th century. Aguas Livre Aqueduct, in Lisbon, Portugal. Aqueduto de Óbidos, in Óbidos, Portugal. Aqueduto de Setúbal in Setúbal, Portugal. Aqueduto dos Pegos in Tomar, Portugal. Água da Prata Aqueduct, in Évora, Portugal. Santa Clara Aqueduct, in Vila do Conde, Portugal. Carioca Aqueduct in Rio de Janeiro, Brazil. Aqueduct of Teruel, Spain. Aqueduct de Roquefort, France, built between 1842 and 1847. Greater Winnipeg Water District Aqueduct, Manitoba, Canada, built between 1915 and 1919. Canal de l'Aqueduc, Quebec, Canada. Pajan Water Tunnel, a 120-kilometer-long underground aqueduct connecting Lake Pajan to Greater Helsinki. Wan Mat Saman Aqueduct, Kedah, Malaysia, built between 1900 and 1909. Surviving Spanish aqueducts in Mexico. Aqueduct of Querétaro, Mexico, built between 1726 and 1738, 1.3 kilometers long and featuring 74 arches. Aqueduct of Morelia, Michoacán, built between 1735 and 1738. Aqueduct of Acambaro, Guanajuato, built in 1528. Chapultepec Aqueduct, Mexico. The F. Kavala Aqueduct, 16th century Ottoman aqueduct in Kavala, Greece. Lavadas, 1,350 miles of 17th century aqueducts on the Portuguese island of Madeira. Espada Aqueduct, built 1735, in San Antonio, Texas, United States. Quabbin Aqueduct, 24.6-mile long tunnel, in Massachusetts, United States. Chicopee Valley Aqueduct, 13.1-mile long, in Massachusetts, United States. Central Arizona Project Aqueduct. California Aqueduct, a 715 miles combination of canals, pipelines, and tunnels, United States. Delaware Aqueduct, in New York State, United States, at 85 miles long, the world's longest continuous underground tunnel. Croton Aqueduct, in New York State, United States. A large and complex water distribution system constructed for New York City between 1837 and 1842. Soak Flow Line, located on Vancouver Island, Canada, is a 44 kilometers long, gravity-fed concrete pipe which provided water to the city of Victoria for 55 years. National Water Carrier of Israel, located in Israel, is a 130 kilometers long system of giant pipes, open canals, tunnels, reservoirs, and large-scale pumping stations to transfer water from the Sea of Galilee in the north of the country to the highly populated center and arid south. Built between 1953 and 1964. Gallery view from inside a Roman aqueduct from the Pools of Solomon to Jerusalem. An entrance to the ancient Poukios, near Nazca.